So it's my immense pleasure to welcome you all to the monthly knowledge sharing session of the PMI Chennai chapter. Today's topic is CASB, Big Data and its role on securing cloud. Our guest speaker today, Mr. Venkataramanan, Principal Engineer Sky High Networks, has over 19 years of experience in architecting and delivering digital TV solutions and is part of the Sky High team, developing next generation big data platforms for analytics for cloud security. On behalf of PMI Chennai chapter, I would like to welcome you, sir.
So I kind of divided this into three sections, where the first section I'm going to talk about CASB, explain about what it is. I'm sure you're going to hear about this term in another 5-6 years. Okay. Then pause for some questions, and then how we solve some of the problems using big data. And then probably I also manage the team apart from creating the platform. And since my journey has been more in terms of evolutionary companies, we don't have to manage 300, 400 people, so we never needed a rigorous practice and tools and procedures. But it would be interesting to see what we see as a good team and what PMI chapter views as a good team and what kind of people you expect to have. Okay. So how many of you are aware of cloud, big data, CASB? I mean, did some of you Google about what is CASB? Is any of you using cloud services in your enterprises? Are you migrating some of the applications to cloud? So is there anybody else, other than IT industry? Can somebody summarize, what sort of industry like you guys represent?
I'm retired from airports.
Oh, okay.
No.
Construction.
I'm
from
ATM manufacturing.
Oh, okay. So it's an interesting mix. Frankly, I don't know how that industry works and how PMI is applied there. But in case what I'm talking is not making sense, please don't hesitate to interrupt me. Okay. So I'm sure you kind of identify some of the logos here, right? Some people might be using Box to upload your documents. Some of you might have seen that your Outlook has moved suddenly from your IT department to Office 365, right? Lot of you might be using LinkedIn, Gmail, and things like that, right? So this is our only end user applications. There is transformation in a big way is happening in enterprise applications as well as in the cloud services like AWS, Microsoft Azure, and things like that, right? And we are quite excited about it, coming from Sky. So you're going to see Sky, and you might have seen my role is in McAfee. It's not that I have changed the job. We have been acquired. Okay, now we are part of McAfee, and the integration is going on. I haven't had time to reflect that on my slides. Okay, so Sky is McAfee, McAfee is Sky, and we represent the cloud business of Sky, McAfee. Okay. So a lot of people are migrating to these cloud-based applications. It's becoming seamless, ubiquitous. We don't worry where it comes from. We all use it. We are happy. Okay, and we are also happy because I'm going to highlight some of the problems cloud has, and we are quite excited about the opportunity we have as a business, right? And we see these numbers. Probably these are numbers at 2050, right? And it would have, I'm sure, already multiplied 2 times to 3 times, right? So as you can see, on an average, in an enterprise like GE or Fortune 300 company, close to 1,000 cloud services being utilized by 2050, and this number is bound to increase even more. Okay. So is any of you use any of these cloud applications? Like how many of you use Box, Dropbox? How many of you think Uber, Ola, and are all safe? How many of you think your data is safe? But still, why you are using it? No fear of data loss, anything? Convenience, okay. Obviously convenience, the ease of use, having your data in every device, right? So sometimes that outweighs the risk, but I'm going to highlight you are taking a big risk, okay? And that's where we have an opportunity, and you will see it soon. By the way, I worked in some of the traffic sharing companies as well. I will tell some experience on that as well. Okay. So, as you said, due to the convenience, due to the pressure in terms of the market demand, the outside factors influencing your company in terms of moving to cloud, the agility, the convenience, the ability to survive in the market, the kind of things it provides, it's easy for a lot of companies, or most of the companies are trying to adapt to these services because of the convenience and the value in it, right? But when we started in 2015, most of them didn't care when I say the C-level executives, right? They were not quite sure what can be a risk, what could be a loss, okay? And they were not clear in terms of how their IP could be, the intellectual property, could it stay safe, okay? Some of this in terms of healthcare industry as well as financial industry, given the US government rules and regulations in other countries, in European countries as well, they have a lot of tight, rigid regulations they have to adhere to, right? In terms of their data usage, in terms of how they maintain this data, how they can store this sensitive data, right? Sometimes what's happening is what we call a shadow IT, right? Shadow IT is essentially all of you use applications, but you use the company network. So you could be using a Gmail for your personal use, but you use it within the enterprise boundaries. Without realizing, it may pose some threat to your enterprise. So a concerned IT manager typically could block it. Like if it's a CSK IPL match, you would be saying most of the employees would be visiting the store page anyway, so let me block it in my proxy. And he's going to, so whenever you hit the site, it would say, this site you are not allowed to view, right? So the easiest way for them is to do that and block you from using all of these services. But at the same time, then you may fear that you are not part of the company. You have the fear of company taking some of your basic rights, right? So how do we balance that? That's where we again come in. So this is the statistics, which is purely out of our system, right? So that's why we had a report in 2015 published. So almost there were 143 files which had the word password, okay, in one drive which is being stored. And we are talking about Fortune 300 enterprises, okay, some of the big names of the industry. Almost 17% of that document contains sensitive data, okay, and 87% of them have migrated to the cloud thanks to Satya Nadella, right? But it is posing huge risk. So is Microsoft not saving you guys? Yes, it is. But to what extent? How? Only when you have lost the data, you may get to know. Or sometimes you may never know that you lost data unless it meets it as a scam, right? And this is the kind of conversation or the perspectives we used to see across business as well. Probably it's true in Indian context even now, right? So the top executive team wants to avoid the external threats. They are saying, when are we migrating to cloud? When are we having agility? When are we having this? Business unit leader says, we always want to improve. We want to reduce the team. We want to automate everything, move all our services to cloud. Whereas the IT leadership and security team is hugely worried because they are concerned they don't want to use the cloud when they have strict regulations to adhere to, right? So Facebook kind of thing happens, you know, for what G's sensitive records or some other companies, right? What would happen? Hell will break loose, right? They are concerned about who is using this data, how this data is getting transferred. So there is a flux, and this probably is what delaying cloud adoption in most of the companies, right? So then there are strong rules and complaints to adhere to as well. And so how do they adhere to these kind of strict regulations when they have to use cloud services, which some cases are third-party services, and they don't have complete visibility on how this is being utilized. So CSA is basically Cloud Security Alliance. They work on the betterment of the cloud. They manage and they basically understand the industry in terms of its developments and improvements, right, and advancements. So they came up with a list of sections where cloud is supposed being praised. Apart from the agility and the advantages it has, your account could be hacked without you knowing it, right? And that could be misused. So, for example, I don't want to name the taxi ride company. The CEO's account, which he used in Facebook, got leaked. Okay, and this account was used because he happened to use the same password, and all the services, the enterprise services, were accessed using the same password. Okay, so that's what we call as account hijacking, right? So when I was struggling in Delhi to book a cab which was near me, and we tried, and it always used to, let's say, 5 minutes or 10 minutes delay, and the driver was just noticing us because we both are standing there. I'm trying to book that cab, and he is looking at me, and he says, "Sir, it didn't happen, right?" I said, "Yes." "Sharma ji karega, okay?" I asked him, "Who is Sharma ji?" "No, no, 50 रुपया दे दो, शर्मा जी करेगा." "Who is that Sharma ji?" "No, no, 50 रुपया plus this thing Sharma ji करेगा." Then he said, he called up Sharma ji. "Sharma ji, book up though." What happened is immediately my number was mapped to that taxi number, and the trip started, and we could get onto the car, and I could have the same taxi experience. The bill came, and I kind of paid him plus 50 rupees, right? So how he managed to do that? That's essentially because some malicious insiders in the company, right? They probably exposed that platform, the credentials and things like that. So a Sharma ji sitting in Delhi can access it the same way a taxi driver is using it here, or the customers who are using it here, right? And I mean, so what I'm telling is true stories, but it's not part of the, just because I'm in security company, right? I have worked in, we also had a section for money transferring during demonetization because everybody wanted to go digital payments because that's a big thing to do that time, right? So they would give out offers. For example, I don't want to name the companies, but if you do a transfer, you will get 25 rupees back, 30 rupees back, 40 rupees back. So people used to transfer, right? And what we have seen is, this is my pure personal experience working with the backend team. What we have seen is attacks emanating from Europe, USA, as well as India as a coordinated attack, where people would use hundreds of SIM cards. Okay, they will put an initial amount, it will transfer along those SIM cards, and finally it will end up in the same basket from that digital payment to the bank. But in that process, they would have taken all the benefits in terms of those transfers, like 25 rupees, 50 rupees, 45 rupees, 30 rupees, which would have accumulated into a big money, right? And so as soon as you put the offer, you will see it's boom. The offer is gone. The marketing chief will look puzzled. What happened to our offer? They would say it's all utilized. Oh, people are so fast, right? That's what they used to think. So that again happens because of malicious insiders, right? And due to the pressure they have, sometimes they don't have the due diligence in terms of how to maintain this system. They don't understand it, they misconfigure it, and they don't realize they have configured it, right? Sometimes the APIs which are being implemented by these startups, I can tell you they are not completely secure, right? So some of these companies is good. They have something called Sentinel team. So the Sentinel team used to hack these APIs, find loopholes and inform the development team so that they can fix it. So that's where some of these attacks would happen via the insecure APIs. Okay. And what could happen in terms of abuse of cloud services is like some insider or a threat gains access to your cloud service. He knows you can scale, he knows you can have billing. What he can do is a torrent kind of effect, right? I mean, he can spin up multiple things, collect everything at one shot, either get out or attack other entities, right? So, without you realizing that your cloud is being utilized to launch attack on others, okay? So, these are some of the industry known threats. Now we know the Facebook threat, so there is a data breach in target and things like that. But as a company, we also have discovered something called knock knock. So internally we named it as knock knock, and we have to vet our threats with some of these big companies before we could come out in the press, right? So the hackers used almost 63 networks, and they didn't do it in a traditional way, right? I mean, hacker typically would hack or spam it with continuous this thing, but now they are more intelligent. What they do is they try for some few minutes of second, they switch out to another IP and try from there. They switch out to another IP and try from there, right? And these things could sometimes not come as outliers. It could look very normal in your system and you analyze each data, right? So, but still, through machine learning and other processes, our scientists could determine that there were 63 networks used and 83 IP addresses, and roughly 90% of this came from China. Okay. So, how many of you know what is S3? Yes. So S3 is an Amazon storage where you could store your documents for your websites, the images, the videos. Then you can use CloudFront to distribute to all the locations so that your sites could load faster, right? So these are typically JavaScript, HTML files, some sort of what you need to make a website. So when these files were stored with improper access rights, what typically attackers could do is they could inject a viral thing into that particular JavaScript engine, right? So when it gets loaded, you would kind of invade that entire network, okay? And believe me and trust me, this has happened with some of the major newspaper journals, media companies where their sites were configured with improper policies. The S3 was not given proper access, right? So the middleman could get into that and kind of create an attack. So with that introduction, and some of it is really happened recently, and these are all facts, so you can check out after my presentation in terms of the news, right? So with that, I will introduce what is TIET. These are the problems is what we are trying to solve. So we are an intermediate broker. We are the antivirus of cloud, right? We align with the existing antivirus system, the security systems, but at the same time, we are an intermediary where between enterprises and the cloud services, we sit in between and we kind of monitor all the cloud services that are being used by the enterprise, and we specifically operate as this particular entity to solve this problem, right? So our business is bound to grow. We have more than 300 Fortune customers are already there, and we are bound to grow. That's why I think McAfee is kind of invested on us. Okay. We also have few competitors, but we are the leaders in this space, and as per the Gartner's survey as well, right? And now we are part of McAfee. So we basically split our product line into two. What we call as shadow IT is some of the applications a user, the enterprise is not providing. The users could do like the Gmail or a media site or a YouTube site or any of this, which is not related to the enterprise, right? Like they could have their own ADP payroll system, they could have their work tasks, they could have their own drive account and all those things. Whereas Shadow is focused on the services you could use within the enterprise domains, right? So we basically, due to our exposure to so many enterprises, we maintain a registry system or a central exchange, and we assess each of these services in terms of their security parameters, and we kind of grade them, saying they are secure, they are insecure, they have these sort of threats with specific things. So we continuously monitor all these cloud services and we maintain their exchange. So when the data which is accessed in an enterprise flows through our secure system, we basically deduct any inconsistent policies in terms of those services and the way they are accessed, and we use machine learning and deep learning to identify anomalies. Okay. So we also standardize and consolidate these services in a category, like basically Box, Dropbox, for example, is a document management system, SharePoint is a management system, right? So we enable you to use all these cloud services safely within the enterprise without blocking you. Because of our risk4 and other systems, your IT department can confidently now allow, disallow some things depending on those scores, right? And they can enforce a consistent policy so that data loss prevention is not happening. So the malicious insider, for example, takes from the enterprise Dropbox account and tries to load a sensitive information, let's say, into the competitor's account. Our system is capable enough to detect that and prevent that from happening. Okay. For that, we integrate with data loss prevention system which are there in the enterprise, or we have our own data loss prevention system. Okay. Then we operate in a completely different spectrum, what we call as sanction IT. These are services we typically classify as what the enterprise or the company uses. For example, it could be your payroll, which is there in the cloud. It could be your document system like SharePoint or Mail or any of those. Or it could be your infrastructure as a service, but that's a separate product category. Here mainly it is about your Salesforce systems, your CRM systems, your box services, your office services. So the enterprise has approved you to use it. They have integrated with your own identity management, but they have strong compliance in terms of monitoring these services, protecting these services, and keeping strict vigilant on the services in terms of how they're being used, right? So we basically generate audit trail for all actions, so that can for compliance. Okay. We detect and prevent any threats in terms of these services. We also audit the usage of these services. So we also provide encryption kind of support. So any data in transit, we basically add on to the headers of that firewall and we kind of encrypt it. So your data is secure all the way till it reaches that service, because we would act as a proxy, right? We will extend some of your DLP policies to the cloud. So DLP is basically the data loss prevention. So enterprises typically have it. I mean, if you do some sort of activities where you are uploading huge content, video or any of those things, they would block it from doing it. But how they would extend it to cloud, that's where we need it. Because they need to connect to our adapter so that we can prevent it actually happening in Office 365 when it is outside the premise, right? So when we say shadow IT, as I said, we basically put in a premise device, then we'll connect it with our cloud connector in the cloud, and we basically analyze all the traffic which is going into that network. Okay. So shadow, as I said, is for an enterprise to keep an enterprise safe when you are using the other services. So we can't determine something which happens outside the enterprise network, but at least we will be able to do within the network, right? So sanctioned IT is what our bread and butter. Here we give you full proof protection outside the network, company networks, inside the company network. So using the credentials of the system, we act as a reverse proxy, either as an API connector or as a reverse proxy, right? So we have API access to each of these services. We are in partnership with them. So if an enterprise account is configured with the right privileges, we can completely monitor what happens to enterprise in regard to that particular service. So in reverse proxy, it's slightly different. All these devices see this as the only server they talk to, but internally we will redirect the traffic to any of those services, right? We also provide full encryption there, so your data is safe. Okay. We also give access control in terms of what you can access and things like that, right? So essentially, we protect all your cloud access in terms of your enterprise .based applications. I mean, it's quite a bit of work. We don't achieve it easily. Some of our solutions are quite restricted by what these API providers will provide to us, but we initially started for Salesforce just to give confidence in terms of CRM security, but we kind of growing and we are adopting multiple service providers. Okay, so I mean, since to provide an integrated solution, we need to integrate with so many entities as well, in terms of the DLP, in terms of the event metrics. So the SIM is basically notification in terms of something happening, right? Key management is for encryption. So we basically go across the spectrum, and some of you might have used Octant as well. So that needs to be integrated for identity management, right? So some people use, I think, Secure now. So so we go across these vendors and we integrate against them as well. So this concludes my first brief in terms of what is CASB, what do we do, right? So our intention is to keep all your cloud services secure, and we do that with three set of products which I haven't captured here. One is a product separately for infrastructure as a service. Okay. So we have IaaS, we have Shadow, and we have Sanction.
I have a question here. When you talk about reverse proxy, I
Right.
understand that most of the SharePoint services generally do not integrate reverse proxies, right? So when the inside out calls to specify or SharePoint, it's typically from the client.
Yeah, it is from the client, but for the client, it is not for the server.
So how do you come in between this reverse proxy?
So we go integrate our agents in that. We go integrate our agents in the enterprise level as one layer, and then we capture them. We don't go to the SharePoint layer.
Of course, but SharePoint doesn't expect any broker in between. So generally, the SharePoint or O365, they expect the authorized client to directly call. So when the API calls when it's exposed by SharePoint or CRM, it is expected to consume only the direct client. So even the enterprise, we do not take the inside out calls through FI reverse proxy or through API gateway.
Okay, I will explain it a bit. So here there is no confusion, right?
This one, so what are you showing here?
We have an API connected to Office.
API and to our client, yeah.
Right.
So this is how it is, yeah.
Okay. So in reverse proxy, right, you keep it only for Salesforce, right? We don't give it for Outlook. Right? So we have both sort of integrations.
Agreed, but the reverse proxy actually masks your internal client IP, right?
It will mask my internal client IP.
Correct.
Yes, for sure, right?
Correct.
So, but that's where we have Salesforce here, not Office 365.
So your solution, will it work for CRM and SharePoint?
It will work in the API connector view.
So that means which expects the direct client to. So in that case, I cannot have your reverse proxy in between
Right.
the client and the O365, right?
Right. So that's why we have two solutions. One is API based, other is reverse.
So how do you then monitor the information that goes out from the client? Because the client here pushes information to O365.
Right. So all the traffic which is originating out of these services, we have authorized access. So we can do on-demand scan to anything.
So you mean to say you partner with Microsoft
Right.
to do this
Right.
packet
Right.
sniffing?
Yes. Yes.
Okay. Thank you.
Yes. So that also is a challenge, right? I think somewhere you will see technology limited by partner API exposure, right? So it depends on that. We are dependent on them, right? That's why when we vet out threats also, we go to them, we evaluate with them because we may undermine their business by exposing them. Okay. So this is an introduction of what we do, right? And that's not my bread and butter. Okay, I'm not a security expert. I'm a big data expert. Right? I'm a data engineer. I don't work in machine learning. I basically manage data platforms. Okay. So why this TIING is a big data solution? Why do they even need me, right? Why can't they just manage with security experts there? Right? So I will make it very explicit. I will make you understand what are the complexities or challenges we have to do. So we typically have this sort of integration with any system, right? So you can imagine this entire traffic flowing through our cloud. Okay? It includes almost multiple of services, multi-tenants, multi-users across regions. Okay, and we, by the way, maintain a separate infrastructure completely for US government, which can be accessed only by the US citizens. Okay. And we operate in European region and we operate in the Central region in the US region. Right. So we have multiple data centers and we operate from different environments depending on the needs of the customer. So when all these services data is flowing through, we almost get 2 billion actions every 2 days or activities from users. So we collect. The data processing we do is almost 350 gig in a day. This I'm, by the way, saying only for statutory. With that kind of data, we are supposed to provide these sort of queries they may have in terms of their access patterns, right? So we need to provide each and individual user how we manage to access it. So you can build a report, you can investigate it, you can see in terms of what is happening. And across these APIs, you also have fine granularity in terms of whether it's a data anomaly, whether it's an access anomaly. We map each and API action to some sort of activity actions across services. So it is like login failure, data download, document upload. So if it is box, this kind of actions will be there. If it is Salesforce, it will get completely different set of actions, right? And through that entire data infrastructure, we also have to come up with behavioral analytics, right? So analytics is, I mean, when you use machine learning, it is humanly impossible to manage. That's why you go to machine learning, right? And when such a huge data is flowing through, you need to determine whether a particular document in a specific location from a specific IP is authorized or not. Is he doing something which is not within the rights of that enterprise, right? And some access for a particular user could come from Ireland, but the next 5 minutes it could be from US, right? Then it is superhuman, right? I mean, it is not humanly impossible, so it has to be a superhuman anomaly which is doing that kind of action. So he's definitely an intruder who is trying to do that, or it's a coordinator. Sometimes what would happen is if they all come through VPN, then they will all look like they are coming through the same geography. In that case, you need to be able to whitelist, blacklist based on particular region, IP, and all this kind of things. So for doing all these sort of behaviors and provide some sort of visibility within 1 hour is a huge challenge. Okay. So we can also basically tell where the user is accessing a particular thing from. We kind of give graphs, and if it is collaboration, we give who are all the users who are linked in terms of that collaboration, right, to a particular document and things like that. So the problem we typically solve is some of the queries you could have on the data, some of the insights you want to have from the data, right? And for us, it's definitely a big data problem to solve because your typical systems cannot handle this kind of data growth, and it's impossible for it to detect all these things within 1 hour, 2 hours of time boundaries. So I won't promise we do real time. I can promise you that we do something called near real time. Right? So when a threat happens, I can't say it will be fixed or it will be notified immediately, but I can say it is within that half an hour or 1 hour boundary to be sure for notified. So we have more than 300 cloud providers, right? So we collect almost 300 gig. I am sure this would have grown even more. I haven't looked at that stat, right? So we typically had all the characteristics of big data, which is like we had the volume, we have a lot of data coming in, and we also had the variety, right? Because a service now is completely different from box, and box is completely different from Salesforce. So all these services are not very similar.
What is that multi-tenant is?
All the tenants, like, so there is one customer who buys our services. There is another customer who buys our services. All the data flow through that. All their data flow through the same pipe. So that's what we call multi-tenant basically. You host all of them in one area and analyze them. Then you give them access to whatever their data. So I mean, what we call as dog fooding is something we also have to practice. We are practicing. What it essentially means is, there is a insider thread within our own company, right? So we also flow our own data to the system, and we kind of monitor that also in real time. So to solve these problems, I will try to capture the big data problem in a simple words, in a simple essence. By no means this is an extensive discussion on big data. Okay, because for that I need a lot of time. Right? In simple words, if your data is less, if your volume is less, you could manage with a MySQL, you could manage with a Spring application, and you will be able to, right? If that volume grows and if your database grows slow, you probably add a queue in between, you will manage it. If your data is really segmented, clearly segmented, you will handle with sharding, right? But none of this would help you to achieve, and the data is huge, you need some sort of parallel processing. Some section has to, so you have to have, so this traditional model is having a function getting executed and the data is coming in, or it reads the data from it. But when it is big data system, the simple philosophy is you don't read the data to compute a function or achieve a functionality. You spread the function to all the data wherever it is lying. Once it has executed, you collect the results. So you basically scatter and carry, right? So so it completely interchange the philosophy in which we will work.
Can you repeat?
So in traditional systems, for example, if it is MySQL, I'm executing a query, let's say. The data comes to that query engine. You kind of process it, then give out the results. But if the data volume is so huge, what you rather do is you send out your function to the data. Okay? Because it's impossible to have all the data flowing, then collecting it within sub-second queries is impossible. So you send out the data, let it execute on all the machines. Once they have executed, you collect the results. So understand big data this way, I think it would be much simpler. Okay, and it would make sense. Because I've seen in my experience, a lot of people say, does this quantify as big data? We are not Google, we are not Facebook, we should do only MySQL. Oracle can scale beautifully for 10 million. So it's completely your access pattern and the type of data you do will determine that. Okay. So understanding distributed system is quite easy. Managing them is quite hard. Okay. So in simple words, it's group of machines working together. Okay. A machine can fail, but it should not affect that group. Okay. they need some consensus because it's group of people coming together. It's very similar to that. They need some consensus in between them to tell who is the leader in doing something. So if you are reading a particular section of the data, a particular person has to say, I am the leader, I am serving this person. Right? So they need to reach some consensus before they achieve that process. Okay? Replication and sharding is inherent. So, how many of you know what is replication? Why we need that? Okay. So it's like our safety mechanism, right? If it is an important mail, you store it in Gmail, you store it in desktop. Suddenly somebody says, what happens if Gmail closes down? What happens if your desktop closes down? So then you store it somewhere in hard drive. Correct? So in distributed system, it is built for failure. Things are expected to fail because multiple people are communicating. A machine's hard drive can go, a machine CPU can go. Right? So to be safe, all these systems, what they will do is, no matter how much data you put in, whether it is for processing, whether it is for storage, it will replicate the same copy in another machine so that it can recover from the data. Okay? So it maintains the same copy of the data across machines. Okay? Why is sharding important? Because the fundamental philosophy is I have to split my function and send it to many places so that it could compute, right? So I don't want to store my entire data in only one machine and then waste all the other machines. So inherently you have to split the data when you send it so that it gets distributed in terms of all the machines. Okay? And it is horizontally scalable. So we use this term vertically scalable, horizontally scalable, it's nothing. If you have a 30 capacity mini bus, you see suddenly Bangalore to Chennai, it is filling up very fast. You can say, I will increase it to 60. Right? Or you can say, I will buy another 30 seater capacity bus and operate 2 of them. Okay? So the second is horizontal, the first one is vertical. So you can keep increasing the capacity of one machine, but it will eventually give up, and the more you go, basically the cost will increase. Right? So in distributed systems, you want to use common CPUs which are available in the market. So you always build it for horizontal scalability so that you can add multiple machines and they can join this group without any issues. Okay. So if you are talking about distributed file systems, so this is in essence big data technologies which are available. Okay. So if you are talking only about distributed file system, it is Hdfs. Right? Of course, there are other distributed file systems available as well, but the predominant one is Hdfs. Right? If you want distributed messaging, you could use Kafka. If you want distributed database, you could use any of these technologies. Right? You want to do computation on distributed system, then you could use MapReduce as part. How do this group of machines work together? You can use Zookeeper for consensus. Right? So, as you see, our system is interactive querying, right? I mean, the customer should be able to query anything at any time. So, we use something called Druid, which is our distributed columnar store. Okay. We also use a proprietary product, which is a vendor who basically provides SQL interface to a distributed query engine. Okay. We call that as CRADE. Right? It has scaled beautifully well. And being a startup, we didn't want to handle the problem of managing Hdfs and all those things. So some of you might ask, Facebook is managing Hdfs for so much of data and all those things. Probably they have the expertise. We have moved on to CRADE, okay, for our reliability. So before I got into the team, it was a startup. It was growing. They are very good in security. They are very good in Spring. They do what they do. Right? They learn from open source. They start a product called Sanction IT, and this is how they build the system. So they went with 1 or 2 customers. It worked beautifully well. Right? It started to fail the moment our incoming traffic increased like anything. Right? So because they were able to do 800 messages per second, and they built all the functionality in one monolithic application, and they served it on all these data stores. That's how you could see the dashboard. Right? This was working beautifully. when we had 2 customers. But we had a sudden growth, right? And this customers multiplied from 2 to 20 to 30, right? And our input rate drastically increased. So this particular streaming application kind of given up, right? It grows. It will have issues in terms of memory. So by the way, did I explain what is batch and what is streaming? No. Okay. Sorry about that, right? So I'll just give a little bit of clarity on that. Ours is threats. Ours is finding malicious attack on a system, right? That's our need. So there is a immediate notion to say when it happens we should, right? In that case, what would you do is you don't have time to process things. So you don't collect something and process. As the incoming traffic comes in, you start processing on it. So typically streaming systems are in-memory systems, and we say they don't use any disks. And of course, they have spillovers, they will use this, but they will use a lot of RAM. As soon as the data comes in, they will start processing. Okay, because they want the speed, they want that kind of responsiveness, right? Whereas the batch systems in Hdfs are inherently slow. Suppose if you run on a large data some sort of processing, the distributed processing, it would take hours for you to kind of get to a conclusion. So for example, in Hive or Hdfs, you run a query, you can go home, have coffee, come back, you would have computed the results, but it's not good enough for your needs. Whereas on the streaming side, you will get the responses back, but the kind of resources it needs, the kind of processing power it needs is really huge, and it is error prone because in streaming, you have to throw away whatever you have processed, and you have to have incremental computation. Right? How many unique activities this particular user has processed? So I can go 30 minutes, count. 30 minutes, count. What happens in between 30 minutes? I lose data. What happens in that 30 minutes? The data which is supposed to be produced on the other side is not produced. What happens? The data arrives late. Right? Your computation is completely gone. But can we completely move away from streaming? That's also not possible, right? So this kind of gave up immediately, right? Because whatever data came in, we kind of changed it form, right, to our computation needs. So I cannot go back when it fails because there is no way there is no place I have it stored, there is no place I have archived it so that I could do this recomputation. Similarly, when the application is stopped working, the other side is producing a lot of data. So now you start the application, it feels the pressure because there is so much of data coming in, it cannot handle. So we went through our struggles. We embarked on our journey on a completely different architecture. Of course, you can Google about it, right? We are privileged that somebody from Twitter was willing to share this kind of knowledge, right? Otherwise, these formulations or these principles would not have evolved. Of course, we would have found out later, but he was good enough to say how they handle such kind of problems. So the particular person from Twitter kind of gave what you can say a Bible to distributed processing. So it's kind of become a framework that a lot of people adopt. So we also kind of adopted. So it says you cannot tackle with one of them. You need to combine all of them. Right? When you combine distributed processing in a batch mode and a streaming mode, how can you avoid all these issues which you are having? So it's a huge topic, it's a big topic, so I will just summarize. Your query is nothing but a question on the data. You can question what is stored in your file disk as part of batch computation, or you can question it on the streaming computation. And there should be a query layer which it's impossible for you to query all the billion records and give you results instantaneously. Alright? So using these two computations, depending on your query needs, you will start building views. Right? So for example, what is my activity count for a user? Then you could say activity, username, user ID, this thing. And you can build this sort of views as part of your documentation. Okay. So you could build this view in streaming, you could build this view in batch, and you basically combine to produce the result. So we kind of change the structure completely. I will not expose a lot of details in it, but we almost have 30-40 jobs running continuously, monitoring, and our SLA today stays at 1 hour. That is, within 1 hour, we are able to process all the data. So we almost get 2 billion records and 340 GB of that data. So there are multiple jobs running it over here, but I kind of summarized in a very simple form. Okay. So when an activity comes in which is a log, we add a lot of details to it because it just comes with one line. Probably the user email or the user ID and the IP address. Now we go to another system and say where in the world this IP address belongs, what is the geography or the country of it, what is the city code. Similarly, we go and add details about that user. We also add details whether this IP can be trusted, whether it is originating from a company, how it is related to tenant and all this. So we call this as the enrichment, right? So as soon as the data comes in, what we do is we accomplish two things in this thing, right? So the preprocessor validates the incoming data for its correctness and stores it as part of Hdfs in the form it comes. So the original data is preserved along with what we do is something called schema. So what is this data which is stored? We also write the schema as part of the data so that it can be read anytime, right? This is typically people use frameworks like Avro and all those things. So you basically store the data along with the schema. It is archived in the Hdfs, but it is also pushed into the Kafka for again processing. Whereas the speed layer, unlike before, will confidently say, I can give you results for last 2 hours. I will not give you results for last 100 days. At any 2 hours or 4 hours, whatever you determine, I have accuracy in terms of what you have computed for that 2 hours. So this entire functionality, the same monolithic application is maintained because we didn't have time to rewrite them and split it into multiple things. So it maintains today for 4 hours of time interval that kind of data. Whereas the batch layer, you could architect it in a different way. You can recompute every 1 day for 100 days. Or you could do incremental. Okay. So what does it mean is like we run our batch jobs on this data, keep producing the same results and keep ingesting them into the storage. Right? But the thing is, if we do full reprocessing, our instance system will have issues. So we still do incremental processing, but we do it in the batch step. Okay. I know it's a little difficult to understand what I'm telling. Grasp it, but I don't know how more I can simplify it. So in simple words, here I collect every 1 hour what is the incoming data, I process. Then that 24 hours I combine for daily processing. That 30 days of daily processing I combine for monthly processing. Right? So you go from daily, weekly, monthly granularity through batch processing, whereas in the stream you maintain only hourly granularity.
So your storage capacity increases exponentially, right?
Yes.
Every day.
Exactly.
Probably every hour.
Right. But storage is cheap, and remember, because these are distributed systems, so they can scale. And not only that, we have 3 replications, so the same data is getting replicated 3 times. Okay. So what we do is, then to maintain the storage at this level, we run some sort of cleanup scripts. So last 10 days, it will start cleaning up from the system, because our contract is to maintain this data only for 100 days. So we clean up the rest of it. So we call that as retention policy. But the advantage you have with prior processing is, suppose one of my developer made a mistake, and he says, I have deployed some wrong code which is computing things wrong, right? Compared to earlier architecture, here I can go to that particular day and I can run another job which will reprocess it. Okay? So you basically combine some sort of inaccuracy with the accurate system, but eventually it will catch up.
So are you storing this data in a database?
It is stored in Hdfs. in immutable form. That is, whatever came in is there always. We never altered that structure because it helps us to reprocess. But whatever we process again gets stored in all these systems. These are again distributed. Right? So trait is like a database engine, so you have to update everything. So you can say the normalized form is stored here. The non-normalized form is stored.
What is Hdfs?
Hadoop file system.
Are you using the AWS technology firewalls? Are you using AWS technology?
I will come back to that in our challenges.
So you process the enriched data or you process the original data?
Enriched data.
Enriched.
Because the original data is not useful, but it helps us to reprocess it. So how to put it right? In SQL, you will normalize it, and anybody can query it in any form. You don't have that luxury here, right? So what we do is we store the data, but if the product team says now in the dashboard this kind of requirement is there, then we'll create a job to compute that. So after a while, they will start using that result of that job. So we'll keep running these jobs for the kind of questions they may have. Okay. If that questions become a permanent thing, they go into the product, and then we have to run the pipeline. So the way we distinguish this in our world is adopt query needs, real job needs, the system needs. So for adopt query for data science, again we have to run these jobs, but they will not be a part of our main computation pipeline.
You are doing this computation only because of producing these reports, analysis and reports.
Analysis reports and dashboarding, like
Only for that purpose.
yes,
Manipulating.
yeah.
Are you manipulating the data?
No.
Are you changing?
I mean we change the data, but we don't manipulate it.
So you don't change the format. What you are storing, you are storing the schema.
Right.
You don't change any format.
I mean
Why do you send the
I capture it in a different format, but I don't alter any of the internal structure. So the way to put it is, I guess. So I have, as I said, variety of topics, right? So for the entire job, I cannot have all the schema flowing, right? So how do I tackle that variety? I define a canonical schema, which is tolerant to all these data formats. So anything gets converted into the canonical format, it gets stored. Whatever you are studying in immutable form, I have a canonical schema, which is like parent schema for any service.
How do you design the schema, immutable schema? How it is possible?
Because we see the patterns, then we map and we come up with a design in terms of Salesforce has these fields, this has this fields, and this has this fields. So it will evolve over time. Of course, it will undergo changes. It will evolve over time. I didn't want to explain it here, but that's the reason why we write that schema also as part of the data, right? So if something has changed in Salesforce, because of that I have to change my schema. What I will do is I have something called schema registry. In a schema registry, we will register with a particular ID each of these schemas, right? Since the schema is stored along with the data, whether in Kafka or in Hdfs, I am always able to decode whatever form it came or whatever form it was adapted, it was stored. So if the form changes, the incoming data will again get a new schema, but they will be stored in that format. So because the data is tagged with that ID in the message queue, I know it belongs to this schema.
Where are you doing encryption?
The encryption happens before the data comes. It's on the other side.
So you will decrypt.
No, I will not decrypt because a data engineer should not see the credit card details, right? So if it is compacted, the compaction, data compaction is run, you should ultimately see again on the tenant side. So we have some sort of key deciphering mechanisms which will decode the final data which is shown here. Okay, in between nobody can see it.
If you want, you can see.
No. Then there is no point in telling the other world that we encrypt everything.
You mentioned about ad hoc and standard query. standard query, is it it is given, or is it dynamic where it finds more frequency of same time of query which becomes standard? Is it learning to become a standard query?
It could be that, or it could be what is defined in the consumable side. The dash would tell this is the feature I have, then I need a way to query. So if the existing system doesn't provide that capability, we have to. Because the read cannot be compromised. Right? So when you use your dashboard, our dashboards, you basically have to see that records in 20 milliseconds or 100 milliseconds. Otherwise the website won't scale. So to give you that capability, we know this is the querying pattern, so we produce the data as well.
If you have a standard set of query in terms of usage,
Right.
how many times that been done? And if you see that you have 100 queries, 10 queries, the time it is used is very less.
Right.
Would you phase it out?
Yes. In Crate it would phase out. In Druid if they query, it will die within the timeout. That's when they will hit upon issues and say, hey, whatever format you have stored is not suitable for us. Can you come up with another topic where you would store these things? Then we will do that. So it becomes another data source, or it could be a sub-view within that particular data source. But data scientists will have this kind of adapt queries because for them to do their machine learning, the models and things like that. So we basically export and import this data to a science cluster. So we give them a separate cluster and they use some other technologies. I know there is something called Impala, Hive and kind of things, but they are slow, but it's good enough for them. They can do adapt querying, it's just that it will take 2 hours.
If you compare this with the in-memory system like SAP,
Right.
which is in-memory computing, so there everything is, we don't have this, whole thing is sitting on top of it and it's very.
Right. So you are right, you could use in memory, but I mean, you could solve that problem in a different way with Druid. So for us, Druid helps, so we have not gone to the HANA level. But
So that is very expensive.
that's very expensive. That's the trade-off.
Yeah, whatever you need,
Yes.
remember you put it over there, rest you can put it.
Exactly. So, I mean, Spark also supports this in some extent. People use something called, I forgot the term. There are so many technologies. There is a Chinese equivalent in-memory thing which is extensively used by the Chinese search company and Alibaba, right? So I think it's not accumulated, something else, right? So what they do is they construct an in-memory grid, and you can store there as key value. So that way also you could do it.
So India is not making any make in India kind of thing, right?
No.
Can you have the question and answers later?
Right.
Let him finish the session and then we will take the question and answers.
No, I'm done.
No, just I want to see that because some answers may come up in the subsequent slides.
No, I'm done.
That's what I just wanted.
I'm done. Since it's PMI chapter, I also wanted to tell in terms of how does our team look like. Right? We have rigorous procedures, but to be a successful data team, I think you need multitude of talents. So how many of you are familiar with fault lines and things like that? Fault lines in a team? Okay. So, so we have a spectrum like the old guys to the young guys. Okay. Some is a generalist. When we say generalist, who can do anything, right? You ask him to code in Python, he will code. You ask him to code in Java, he will not say I'm a Java guy. But you also need the specialist sometimes. Right? So there will be a data guy who is specialized in certain technology like Hive, MapReduce. There is a certain guy who is specialized only in machine learning, right? And then also you need some sort of guys because the amount of data we expose is huge. It's not your simple REST service. Right? So though we use Spring and all those things, we have to become cloud native. So that's another technology like 12-factor apps and things like that are there. So we need some guy who can build these APIs faster. At the same time, our team has to be smart, right? So ours is typically a 10-member team with multitude of skills and different age levels. So in my experience, I think that's how you should build a data team because you have somebody who is curious enough to explore the particular thing, somebody who is mature enough to focus on only one thing, right? You need that spectrum of broad skills. Okay? Very often we make mistakes, right? And you don't punish them for that. Because if you punish them hard for those mistakes, your psychological safety in the team is disturbed. I mean, this is management term. Google about it. So as a leader, I think my responsibility to is give them that confidence to say they are allowed to make mistakes, they are allowed to have issues as long as they realize why they made it, in what context they made it. Having such a small team also gives me a challenge that we have to automate everything, right? So I can't have a cluster, do some solution, then finally go to the field or production and you have billions of records flowing in and you cannot afford to fail. So what we do is our QA developers can code as well and they have a strict mandate to automate the pre-testing, right? And they do it on the production system. So we call that as synthetic testing. They produce some test data, they have to validate the pipeline. So their jobs run along with our main jobs, always indicate us in terms of how our release is doing, right? In terms of any of these issues or the outages we put in. And we always make our decisions, being an analytical company and a small company, only on data. I mean, there are no subjective opinions. You cannot say this technology doesn't work, that technology doesn't work or anything. The context is set for anybody to oppose anything, they have to come up with it, right? But we operate in a very sensitive industry. We can't afford to have security issues, we can't afford to have data breaches and things like that. So we have rigorous procedures. So what I use this word, I don't know, there is an industry term for that. Anything which needs to be done right, automate it. Don't allow any human to get it. What do I mean by that? If a build needs to be deployed, it needs to go via only the continuous build procedure. If a code needs to be committed, it cannot escape the code review procedure, right? And make it extremely hard in your environment to have bad habits. What do I mean by bad habits? If somebody wants to deploy something in production without our knowledge, make it extremely hard for them. He needs to get some permission there, here, there, right? So do the good things, automate them, make the bad things extremely difficult in your environment. Think about it, I don't know what is the term to use for it, but this is something I really practice because then it avoids a lot of conflicts and challenges. So we have to innovate because our ecosystem, as you said, is keep changing. We have multiple technologies coming in. So I never allow them to eat the elephant fully. I give them a specific portion and say you can change it here before you bring in a big change, right? So I am not averse to change. We are very welcoming to such change, but we allow them to do it only in a small space before we validate it and it can be scaled. So for somebody says, freight is expensive, we should use something else. Something else, did you guys check this? So in our environment, it's very dynamic. The Spark, for example, has gone through multiple evolutions. Kafka has gone multiple evolutions, and it's very difficult to keep pace with those changing versions and things like that. What was there in Kafka 0.9? What is there in Kafka 0.1? Now I remember somebody, I think she asked EMR kind of things we use, right? So this is the biggest challenge we have, right? Our SRE teams and systems need some sort of improvement. This is one of the pain points we have. We are moving towards EMR, but there are some challenges. For example, if it is government-based thing, I cannot just move on to EMR, right? So we maintain our own data centers for this needs. But sometimes it's challenging to maintain the systems in a consistent way. You have to keep maintaining those machines. You should ensure none of them fail and all those kind of things. But at the same time, on the other side, we want agility. So we are thinking of moving to EMR, but at present, we use everything in our own data.
So when you talk about data has classifications, right? The enterprise has a policy like confidential data, strictly confidential, and official. So how do you ensure your SLA meets with the enterprise classification policy?
So could you elaborate on that? Because data classification, you are talking more in terms of metadata management.
No, see, when you say data when it's talk about data, it's a mixture of information. Some is official information, some is strictly confidential. So as per the enterprise policy, this enterprise, the official only or let us say the confidential and strictly confidential data is not allowed to go beyond the boundary.
Okay.
Right? So we don't share that with anybody. So,
Right.
so when we store our documents in SharePoint, CRM or CRM or SharePoint, so we have strict SLAs with Microsoft.
Right.
Right. So we enter into such kind of an agreement.
Right.
That's with the company CEO of the Microsoft. So then we bring in third-party companies like you who act as a reverse proxy in between. So we ask you to inspect our data and give us the intelligence. Right. So what is your commitment as a data analyst?
Right. I will answer that in two parts. The fact I am not exposed to it clearly tells you that, I mean, I was telling you like US cloud, we have our own separate data centers. I don't have access to any of those. How they do it, I don't know. But if you go to our site, so I'm completely forgetting the metadata management part. Okay. Specifically to your question, I think you have all the A to Z, all sort of alphabets in terms of certifications, and we undergo rigorous auditing procedures as far as I know. But how they do it, who does that, I don't know. Okay, because I don't have access to information. I have only the bastion or the entry level access where I can take data in, data out, deployment. I mean, I don't have any clue on that because it's managed from the US.
In terms of environments, for your research and development, you said QA team does testing directly in production. So for your research and development, you have different sandboxes.
Yeah, we have something called QA stable, QA run, performance test, okay, and developer environment, right? This is something I liked in my taxi companies where I could spin up things in the entire structure the way I want. This is something I don't think we do it right in Sky, but this is again my personal. So in Sky, I think everything is integrated fully. So from the dashboards to everything is integrated. Yes, of course we do. But the problem I always found with that such environments is that you never going to have the traffic the requirements of real life, right? They can never replicate that. So it can be there for your initial validation, but I still insist, I mean, as a team, we still insist, we believe we need some sort of automation and validation always happening in the production system. Okay, so we do have these environments, but we do validate in production.
That doesn't pose any threat in terms of data because you're directly accessing the production. Something goes wrong.
No, we get onboarded as a separate tenant. So to the outside world, we are another entity who are getting onboarded. So it happens through formal procedures, but we use that particular tenant to validate.
Okay, just to rephrase this question, how do you ensure that the stream data which comes in, okay, it may have like certain attributes on the data, like for example, usernames, which you don't want your development team to see because it's production data, ultimately it's for the client. So there are certain information which you don't want your test team to have access to. So what kind of steps do you take to ensure that there is anonymity?
Yeah, so this is done separately from a team called proxy. I mean, I don't manage it, but just to illustrate your point, the moment I receive the data here, either it is encrypted or non-encrypted. If it is non-encrypted, the customer himself has not opted for that option. But otherwise, it is encrypted for sensitivity. So that provision would have happened. The data, when it is getting published from there only, it will travel as encrypted.
Yeah, I understand the travel part and the encryption and the decryption. I'm talking about decrypted data because when you deal with production data, once it's decrypted, you have access to, like, say,
I can never see decrypted.
No, after your system to process it, it has to be decrypted, right?
No.
Okay.
Because, like, for example, user name will be encoded it in some name. As long as there is an intermediate system to understand that encrypted fashion, that's all we do.
Okay.
So it's the final visual thing will be decrypted. So it is just seen as a single data.
This
So
restriction, this restriction, what you're saying, like you are not able to see the data, Is it self-imposed or it's a system imposed, or who is the intermediary coming in between? Like, I mean,
It is the guys who onboard data to our system in terms
Hmm.
of the partnership or the business agreements they have with the particular entity. So the guys who, so we are a processing engine. So they say, hey, I have this customer. His data is going to come for you as equity because he wants it.
but if you want to see, is there a provision like, I mean, you can.
I have to raise a ticket, ask a dashboard particular entity, for
Oh,
example.
because you brought this one was malicious intruders.
Right.
So
They can't see it. I mean, unless they raise a ticket, they undergo a CCB procedure. So that's why I said we are a startup, but we have rigorous practices. So even for me to access production data, they can't. So if there is a need for me to investigate a bug, they will give me a sample.
Okay.
Right. So I cannot just do SSH. Okay, now I am seeing this production. No, you cannot enter.
But you also mentioned about storing in canonical form data, but that I assume is certain.
Yeah, it is again protected. I mean, I cannot enter into the system because we are approved. Okay. So, though I am the lead today, I can't deploy applications in the production. And if it is Go Cloud, I don't even have access. They will tell what is the symptom they are seeing that they have repurposed. So there is one authorized person. To him we say, this is the release cycle, this is the ticket, he is the authorized person who can deploy these things. So for everything we undergo something called change CCB board. So though I manage the team, I have never seen the data. I mean, in QAT yes, QTS yes, but not the first.
So then how do you prove it to the customer? Like the end result will be what they want.
So if there are customer ticket, see this is the identified issue, then we'll get some sample of data. Then so it goes through a process of interaction with the particular team. The SRE team is getting the data out in some portion to see what this is. In case we are not able to solve, that's why it's challenging. That's why we have to automate, because we have multiple tenants. The kind of producers can make all sort of issues, all sort of things. So we do have some sort of incidents here, right? I mean, if I see a tenant is producing data more than its permissible rate, we drop it. We raise alerts. Okay. If a producer is not adhering to a format, we raise alerts. So there are a lot of things which I have not drawn here. Where we say blacklisted tenant, whitelisted tenant, invalid buckets, a lot of things. So we also provide some sort of automation and monitoring of it. Unfortunately, I can't show all of them, but I have a lot of systems to measure. I mean, at any point in time, now I can know what is the success rate of my jobs, what is the SLA, what is my queue backlog, who are the tenants who are getting dropped, and so on.
See, I have a question. See, you said you have a master schema which gets evolved over time. So who does it and how it gets
We want it.
evolved? So you see the content and you see the structure by which you go and keep changing the schema.
I mean, I can see the structure in my QA. I mean,
So
I
does
don't
it
see the
happen
actual
manually?
data.
So you manually you change the schema so that you maintain the master schema over a period of time.
Yeah, we have a schema registry, we maintain it.
So it
So,
doesn't happen.
for example, one of the changes would come is like, I'm just making this up because I don't know who is the actual customer, but let's say your organization is split into geographies and you could onboard to us as one organization, right? Let's say Pratik Systems, right? But your data could be coming from Pratik Europe, Pratik something. So for example, somebody says we need instance ID for our data because they see them as instances. So they sell the product as one entity, but each instances are, I mean, separate by themselves. Now, if I have adopt this particular feature, I have to change my schema because we never had that notion of one tenant having multiple entities coming as one tenant. So you could either onboard them as separate tenants and charge them, but they don't want. Then it changes your schema because now you have to allow access across them because the IT department is same. So we may undergo some schema changes. So whatever data which was incoming, by the way, I think that's why it's confusing. We align all our releases, okay, on a 4-week cycle. So analytics has to make a release. Proxy or the guys who determine this producer form, they have to make a release. Dashboard has to make a release. So probably that's where these features all get added in a synonymous way. And we know from that release onward, this will be the data structure. So then we maintain. So based on the schema ID which comes in, we know this is the schema to decode, this is the schema to decode. So it could handle both old and new.
You said that you also use machine learning.
Right.
Why do you use machine learning?
I'm not a data scientist. They basically deploy some algorithm. I mean, they give it as a package. They deploy it as some algorithm. So what this algorithm will determine is, we give them the set of activities, and they will produce some sort of counters. We will say this particular activity from this user happened so much time in role and all this. Now these algorithms are intelligent enough to say this is the outlier. It could map this data coming in from different systems because you could have used mobile outside and say these two activities matched, and it would be able to determine that this behavior is outlier. So I'm going to tag this as anomalous activity. Then there will be a rule engine which will determine, because these anomalous activities from machine learning could be false positives. So a machine learning guy would explain it much better. But basically you can say it's like a human determining whether this particular activity is correct or not. Right? It could be your data anomalies. I mean, I'm uploading or downloading something beyond my limits. I'm accessing something from different places. Now it will combine all these false positives, and the threat system will determine whether it is really a threat. For that, it would have some sort of rule engines to say this happened within this interval. So over the time, that rule engine will keep evolving. Today we use rule engine. I don't know more details on that, but I think we'll move to deep learning as well. So then you don't need rules. The system will learn over time.
So to determine the threat, are you using the data science or machine learning? Which one? Big data you are using.
So what is data science? What is machine learning in your understanding?
To classify or to understand
They are same fields. So what they will do is first they will use an evaluation procedure to model their algorithm. Once the algorithm models, it becomes a component technology. They will deploy it. They will keep improving. So the data science will just use that to validate. But once they say this is the behavior and the engine can be deployed, they will deploy it and they will keep improving this engine to this, what you say, constant updates, where they will again, run it through multiple algorithms, change things, change thresholds. They call it as baseline thresholds and all. So they will say, for this tenant, these are the thresholds. Given these thresholds, this is the behavior. So a tenant, before he is onboarded, his past activities are taken. It is fed to the system. It learns. Based on that, it will set the thresholds on the real system. So it's not a separate field, it's a combination. I maintain data systems. I don't have exposure on that, but I have some fundamental understanding where they use some sort of algorithm. So if you feed the set of activities, the algorithm is intelligent enough to say it's an outlier. It is a different one from the rest of them. And you combine multiple outliers and you learn over the time that it forms a threat. That's where it becomes a rule engine. But I think they are working towards it because rules is also not scalable. Right? So they are working towards it. But right now I don't know.
anywhere rules can be scaled to section. Any rules.
Any rules based on these anomalies, you could say, for example, box for this tenant, any tenant download, if this exceeds this threshold within half an hour 5 times, you could categorize it as. So, I just did some one of the slides of live interaction. So, this stuck with me until today. This is not mine. This is the University of Illinois. But to manage a change, this is what you classify, and I've seen this work in real life, right? So I think one of the things as a leader we need to do also is to set a right context. To put that in an example, I can simply say, we have to improve the resilience of all our components, right? 5 people listening to that would interpret it completely different, right? And if they interpret it and if they see that as a challenge or lack of clarity, we're going to have resistance to a lot of it. So I think this says most of the time to it. And being a small team, I think probably helps. That's it.